सो हेलो एवरीवन, आज हम कोड फोर्सेस का कॉन्टेस्ट 759 जो डिवीजन 2 के लिए रेटेड है वो सॉल्व कर रहे हैं। तो लेट्स बिगिन। सो पहला क्वेश्चन हमारे पास क्या आता है, लाइफ ऑफ अ फ्लावर। अब इसमें क्या है कि पेटिया के पास एक इंटरेस्टिंग फ्लावर है, वो एक बिजी पर्सन है, सो ही समटाइम्स फॉरगेट टू वाटर इट। यू आर गिवन एंड डेज फ्रॉम पेटिया's लाइफ एंड यू हैव टू डिटरमिन व्हाट will happen to the flower. The flower grows as follows. The flower isn't water for 2 days in a row, it dies. If the flower is water on ith day, it grows by 1 centimeter. If the flower is watered in ith day and I minus 1th day, it grows by 5 centimeter instead of 1. If the flower is not watered on ith day, it does not grow. After being the beginning of the first day, the flower is 1 centimeter tall. What is the height of the flower? Each, so we will be given a test case, the number of test cases, the number of days, and 0 or 1. Okay, so we have to find the flower height of the flower. So we can do this by checking that if there are two continuous zeros, the plant will die and we will get an answer of -1. And if there are if there is a 1, it will grow by 1, and if there are consecutive ones, it will grow by 5. So now let's code the solution. Here int n initializing the answer with 1. So now we will read all the days. Int rev equals to 0 because we need to store the previous state for obvious reasons, because the previous state will determine what will happen if the current state, and we are storing it with 0 because no, we should store it, initialize it with -1. For int I equals to 0, I less than n, I plus plus. If now int s c in s, if not s, if s is 0 and not prev, then answer equals to -1. Or should we do a better way? And there's a better way, I think. Vector of integers, days for int I equals 0, I less than n, I plus plus, c in days I. So further int prev equals to -1. For int I equals to 0, I less than n, I plus plus. If not days I and not prev, then answer equal to -1 and break. We don't need to go further. If not days then we will simply prev equals to 0 because there is no growth if days I. Now if days I, I think we should do one more thing. If not prev, answer equals to -1 and break. else prev equals to 0. Now if not prev answer plus plus and prev equals to 1, else prev this statement should be here, answer plus equals to 5, and at the end so this is the thing, we are reading all data of all the days, and we are initializing the state of previous day with -1 for obvious reasons, because if it is 0 and the first day he didn't water the plant, it will die. In that case we don't want that. We should also, because we should also be looking at the second day, so therefore -1. And if there is if something is not done on day, he has not watered the plant, and on the previous day too, if the previous state is also 0, so answer will be -1. It means the plant is died, and we will break the process here, because we have finally gotten the answer, and damaged plant won't grow. Otherwise if he has just forgot to water on that day, but if it and it's the first day or in mid, and he has watered earlier, then the previous state will be set to 0. Now the else will go to if he has watered that day, and if he has watered that day and didn't water on the previous day, then the plant will grow by 1, otherwise it will grow by 5, and the previous state will be set to 1. So now after all the iterations of the loop, we will get to the answer and we will print it. Let's see if it works. We have the input here. Okay, there is an error. Okay, so I missed a semicolon. Okay, let's see what does it print. 7 7 minus 1 1. Okay, let me check. 101, and this should go to 2 0. No, okay. Prev is set to 1. Let me check. C out PREV PNDL. We will go for just 1 3 1 space 0 space 1. Prev is 1. Okay, so then prev will be set to 0. Okay, I think I should find out why is it going in this region. Let's see. One space 3 space 1 space 0 space 1. Okay, it's going here for some reason. Let me check why. Prev is 1 here. Why is it has not been set to 0? Okay, should I remove the else? No, why is it happening? Not this I. And I should do this to C out. Answer in line. Wow. Okay, so this is the reason it's sending it directly to 5 on the first day. I think there is a better way for this. I think we should go from 1. And int prev equals to days 0 and answer plus equals to days 0. This should work. I think 1 space 0, 3 space 1 space 0 space 1. Yes, it's working. Now let's remove all the debug thing we made. Now let's run, copy it again and see the answer. 37 minus 1. So here it is, we have the answer. Now let's upload it. Submit code. A okay, this is in queue. Pre-tests passed. So now let's move on to the second problem. Array eversion. You are given an array of length n. Let's define an eversion x equals to a of n. Then array is partitioned into two parts, left and right. The left part contains the elements of a which are less than or equal to x, and the right part contains elements which are strictly greater than x. The order of elements in each part is kept the same as before the operation in the partition is stable. Then the array is replaced with the concatenation of left and right parts. So that 2 1 4 5 2 1 3 4 5. Okay, we start with array A and perform eversion on this array. We can prove that several inversions. After several eversions, the array will stop changing out the minimum number k, which will be needed for this to happen. Okay, so we can clearly see that when this will stop when the element to the right is the maximum value of the array. So when will it stop? So let's see. On the first for the rightmost element, we need to find all so here let's see in the examples, the largest element is 5. It is given. Okay, after the first, and this is the second one. Okay, it's already sorted. Okay, so we have to find out. We can simply do this by using okay, if it is, let's say it is 5 4 3 2 1, then it will go up to n square, because each iteration will just shift one element to the right. It will be just right rotation, so we can't do that as the range of n is 10 to the power 2 into 10 to the power 5. So we need to find a solution which works with the complexity of n log n, something like that. So let's think for a minute, what should we do? First we should pick the largest element, which is 5, then to the right of it the largest one, then to the right of it the largest one. Okay, this should work. Yes, we can do this by the following logic, that for Yes, we can do this. The following thing, that we will find the largest element, and if there are multiple copies of the largest element, we will pick the one which is at the right, which is on the which is at the rightmost. Then we will find an element to the right of it which is smaller than that but also the greatest among this, the similar thing, and we will do this up until we reach the end of the array, and the number of times in which we have to do this is the answer. But then again, I think it can go okay, if we think correctly. uh-huh. Okay, we can do this via map. So on the program, the solving the B problem, int n, the size of the array, vector int nums n for int I. Now we will I think that should be better. Map of int comma int I n t. For int I equals to 0, I less than n, I plus plus, int x, ind of x if ind dot find x is at the end, then ind x equals to I, else ind x equals to max of. Okay, now I think I should do changes here, which we are using the int. Sorry. So this will work. Int x of we should use amax ind x comma I. So this will assign ind x the maximum value among ind x and I. Okay, no. It's already the greater value ind x equals to I. That should be the case. Now for auto itr equals to ind dot r begin, and there is also int answer equals to 0. itr not equals to ind dot r and r plus itr plus plus, so we will start from the end. Okay, why is it? There are typos. Well, that doesn't change much for the things we will be facing. So, and there is also int I equals to n. Okay. no, should be -1. Star of ind dot rend. No, second. -1, because we are looking to the right of that index. If itr dash second is less than equal to, no, because less than equal to I break. No, not it shouldn't break. If I equals to n-1, then we should break the system. If I equals to itr second, then we should just continue, because this doesn't help us at all, and the previous element is not coming to help us because the partition is in order. Now what we will do then, answer plus plus I equals to itr second. Now see out answer. Let's compile, see if there is an error. No. Let's copy the sample test. Okay, there is an error here. I think we are not, okay, we are not scanning. C in X. What? Control Alt. Let's see what the output is. 2, 4 and 0. Why is it double the required answer? Okay, so okay, so it starts with 3. Okay, 5 and 4 is not 5 and 4 is not equals to n-1, not breaking. It is equal to second. Yes, it will continue, nothing else. Okay, then it will reach 4. Okay, so here is no 4. If I is equal to n-1, okay, so wait, it should be greater than equal to. Okay, now it is outputting the correct things. So here is our code. So basically what we are doing is, in the map of int comma int, we are storing the number, the element as a key, and the value along with it is the maximum index value at which it is occurring. So, and as the partition is stable, so the partitioning will not change when the greatest element will come to the end of the array. So the greatest element will be brought to the right by the element which is exact which is the second most, which is greater than that, but also which is smaller than that but greatest to the right of it. So we are finding how many jumps like that we will require. So that's the basic idea, and we are implementing that here. And I think we should also maybe remove this part. Okay, and the basic logic here is if the system reaches at the end, the II is the index at which we currently are. If we reach the end, then we will break. If the element over which we are iterating is to the left of current element, it is not helping and we will continue. Otherwise, if it is helping, it's on the right, then we will add to the answer and take it index to the current one. So that's the basic idea. Now we will submit the code and check whether this is correct. Okay, so as you can see here, it's passed. Now let's move on to the third question. There are total n number of depots. A total of n depots are located on a number line. Depot I lies at the point xi where I is 1 to n. You are a salesman with n bags of goods attempting to deliver one bag to each of the n depots. You and the n bags are initially at the origin. You can carry up to k bags at a time. You must collect the required number of goods from the origin, deliver them to the respective depots, and return to the origin to collect your next batch of goods. Calculate the minimum distance you need to cover to deliver all the bags of goods to the depots. You do not have to return to the origin after you have delivered all the bags. Okay. So 9 3, then we have the locations. If okay, so basically if a location is 0, we will exclude it completely because it's on the same place. And now let's check what are our constraints. Okay, we need a solution which is O of n, because yes, we need it. So so basically what we can do here is that we will separate the given positions into two parts: the positive locations and the locations which are on negative indexes, and we will group them accordingly. So 2 2 3 8 6. Okay. And then okay, and for the negative part we have 3, then we have 30. Let's okay, and for the right we have 3 4 5 6 7 and 8. 3 4 and 5 to, so 15 to the 30 plus 3 4 5 to 10 and 8 6 7 8. This is 48, which is surprising. Okay, that's can be wrong. So 30 plus 8 is 16 plus 5. Okay, 41. Valid answer. So we have to choose for that whether we should go to the end at the last, or should it be done at the very beginning. Because if it is done at the last, Like for the next example 22333, here on going to 2 it is, and returning is better choice, and instead of going to 3 compare 3 and okay, if we go to 3 and okay, then it is 8. Okay, so what should we do here? Here for the negative part, it's visible that we should go and come back in one go. We need to work something out, that what is the better strategy. The total is 30 here, so 5 3 4 5 6 7 8. What should we do here? We have to choose an optimal approach. Okay. Well, let's skip this problem for now. Should come back at it again. Yet another sorting problem. That there has an integer array of an. He only likes sort relatives and if can be arbitrary, so we have to sort using cycles of 3. We are to use 3 different indices. And apply I to j to k to a cycle on the array simultaneously. Simultaneously ai t. Okay, so okay, so we have to determine whether it can be sorted or not. Okay, this is the question for cycles. Well, we can do this by following that we can leave the in place items and check if the length of the check for the length of the system. 7 and 1 1 yes, 2 2 2 yes, 2 2 1 no. We have to make cycles of 3, otherwise it is not sorted. And 1 2 3 to sort it. 2 1 3 2 1 3, it will only go to 3 2 1, and it's fundamentally broken, so no, it can't be sorted. 3 1 2, yes, it can be rearranged to 1 2 and 3, and 2 1 3 4. Let's see. We can rearrange it to 1 3 4 here. No. 1 4 2 can be better choice. Just so what is needed here? Okay, let's see if we choose the location to be the last one here. If we are choosing the location to be the last one, one, two, three, four, five. Okay, 0 to 1, 0 to 2, 5 and 1. And we have to go to the 5 at the end. We have to go to 5 at the end because that's what often is. Or should it be? Yeah. Yes. Okay. And the minimum value is 5. Okay, so 5, 0, 5 and 10. We need a no offense solution for this, otherwise we will be getting errors. Not error, time limit exceeded. Let's think for the problem C. We have 10 plus 8 or 8, 16 plus 5. There is already 30 from behind. This is 16. Okay. So we are going left at the end. That's also troublesome. Which is 10 plus 16 plus 15, 41. That's how it is. Two, 3, 3, 3, 6, 3, or okay, we have to divide it in groups, and the group which is the furthest will be reached last. Okay, simply 3 will be reached at the end, 15 will be reached at the end, and here 5 will be reached at the end, and all others. Yes, that's acceptable. So yes, here the basic idea will be we will find the place which is located at the farthest distance, and that place should be visited at the end. I think that should give the best answer. So here 15 is the farthest place, and we are doing in order to preserve the total amount, that the total distance which we have to travel. So in here 15 is the furthest, so it will be achieved visited at the end. So 15 in the path, it will take away 10 and 5, so we have 15 in the answer. And then for the positive part, we will first go 8. 8 will take away 7 and 6, as we all know. Then 5. So let's start writing int n comma k cn n k int farthest is equals to 0 for, and we will also set int positive distance, set int negative distance. For int I equals to 0, I less than I plus plus, int x c in x far. Oops, spelling error. Equal a max and farthest comma x abs of x, we should, and if x is negative, then if x is positive, we don't care about zeros. Because we don't, why are we not worrying about zeros? Because they are at the same place, we don't need to visit, they can be, the packets can be delivered there without any problem. And also one thing, this flag variable will check whether the farthest distance which we have found is positive or negative. And yes, there is also a okay well, doesn't matter if the farthest distance is positive or negative, it because if in both cases we have 15 at both ends, we will have to visit both of them. abs of x is greater than farthest So now we have taken the input, let's proceed to answer the question. And we will remove k items if flg, then if flg, then for print I equals 0, I less than k, I plus plus. We will be removing the element at the end of the if FLG is true when x is positive, so we will be removing k end elements from the system if not pos.dis.empty. It shouldn't be empty. pos.dis.erase pos.rbegin, because we need to remove the last element. And else 0 okay. If not negative dot empty dot r begin. So here we are done removing the last k element. Now we have to do this for both sets one by one. Then while pos this not pos this dot empty answer plus equals to 2 star pos this dot r begin star. Because yes, it's an iterator, we have to dereference it, and we can copy this. And then we will be doing similar stuff for the right part for the negative. Okay, and I forgot to do one thing while taking the input. Negative ABS absolute value, we don't need negative values here, and here there is n, there is pos underscore dis. Oops, neg. Now see out the printing the answer. Let's try it out. Okay, we are getting an error. Where it is? Okay, this will not work. Now this is previous of positive dot this dot end. We have to use this statement. This is quite a heavy one. We will just change to NEG. Okay, let's first clear the terminal. Will it work? Let's hope it works. 2541. Okay, 3. Wait, what is happening here? And What? Answer equals to furthest. Why is it not working the way it should? Is it not erasing the elements accordingly? It should erase two elements from positive 10 to power 9. Okay, I should also consider changing the it from integer to long star 1 ll. Okay, here we need objects. Adding a breaker. Okay, I found the problem. We are using set. We should use multi-set, because yes, we have multiple values for the same position. Let's see what does it print here. Yes, it's the answer we needed. Okay, so let's check the submitting it. Problem C. It's running. Okay, it's passed.